AI being used at such a large scale, accessibility to open source toolkits have become a huge priority. Familiarity with such toolkits and building trustworthy AI systems, they go hand in hand. And to explore the intricacies of this, open source toolkits, that is, for building trustworthy AI systems, joining us next is from San Jose, California, is Saishruthi Swaminathan, who is the advisory data scientist, AI strategy and innovation at IBM. She's passionate about data sciences and thrives on the skills required for transforming data into useful products. So let's hear from Sai Shruti. Welcome, Sai Shruti. Whenever you're ready and you see yourself on the screen, you can start speaking.
Hi, thank you for the warm welcome, and thank you for having me here. I hope you all can see my screen now.
Yes.
Yes. Perfect, awesome. So let's get started then. Hello, everyone. Thank you so much for joining me today. And I usually start with a note of gratitude because time, I think, is the most precious thing that you can give to someone. So I genuinely, from bottom of my heart, like, thank you so much for joining the session. And I hope you are enjoying all the sessions and looking forward to share the knowledge that I gained for the past 3 years in this field. And I hope to empower you with the tools, technology, and concepts required for building trustworthy AI systems. I'm here today to create this safe space and discuss about open source toolkits for building trustworthy AI system. And with little bit of introduction about myself, I'm Saishruthi Swaminathan. I work as advisory data scientist in AI, in IBM's AI strategy and innovation team, and I'm a trustworthy AI advocate. I have been in this trustworthy AI field for over 3 years now, and I'm here to share with the knowledge that I have gained and that I believe will empower you all to move towards building trustworthy AI systems. So, we are in this together, and let's get started. So, why should we care? Right? AI is incredibly important. We interact with them every day, right from traveling in getting intelligent routes to travel faster, in our emails, for example, spam filters, autocomplete, and so on. We interact with a lot of AI system on a daily basis, and we enjoy them. But for companies, the incentives are around revenue, making them more efficient via better products, right? So in 2018, McKinsey estimated that by 2030, AI could add up to $13 trillion to global economic output. And definitely there are so many opportunities in the field of AI, and all of us are super excited, and we are looking forward to what we are going to accomplish through this artificial intelligence technology, right? But opportunities come with risk as well. Just a second, make sure everything is good. Yeah, opportunities come with risk as well. Why should we really care about building trustworthy AI system? And let's see some examples. In June this year, there was another news of facial recognition system causing negative impact on people's life. An innocent person was wrongly arrested. So he had his driving license photo, which was compared to a surveillance video of a theft by facial recognition software. The system concluded that they were same person, which led to the arrest. And second example, issue with speech recognition system that misidentified up to 35% of words from people who are black. Third example, issue with image recognition in Twitter cropping feature, which identified people of one color over the other. And finally, the ever ongoing issue with bias in recruiting. So these are some of the example, and kind of gives us the essence of why we need to really care about building trustworthy AI system. So what can we do? How can AI system earn the trust? First, it is what we need right now is much more than model accuracy, right? We need to really care more than the model accuracy number. First, is my model fair? Does it treat everyone equally, fairly, right? So, particularly, we tend to focus on historically underrepresented group. Is my model treating everyone fair? Next, is the process transparent? Am I able to infer what has happened to my data and model and the decisions that were taken throughout the life cycle, right? Is my model explainable? Will I be able to tell why my model ended up giving this prediction at the end of the process, right? Is my model robust against attack? And finally, is my data protected? So these are some of the questions that will help us, move towards building trustworthy AI system. And this is much more than what we really care about, which is the model accuracy. So, keeping all these questions in mind, here comes the pillars of trustworthy AI systems. And they are fairness, explainability, transparency, robustness, and privacy. I'm going to empower you all with the toolkits, with open source toolkits for fairness, explainability, and transparency today, and hope you all will be able to take this learning forward and then start thinking about how to incorporate these into your pipelines. First is fairness, right? So what you're going to see about is what is fairness, what is bias, what is unwanted bias, and what are the open source toolkits available here. First, let's understand what is bias and types of bias, right? So I particularly feel this session, at the end of the session, we should really understand certain terms like what is bias, what is unwanted bias, what are the toolkits possibly available in the market in open source that you can take and try to add it to your pipeline. So that's my focus and that's my goal for today. So let's start with bias. So, bias is a systematic error. So, in the context of fairness, we are concerned with unwanted bias that places privileged group at advantage and unprivileged group at a systematic disadvantage. And bias can occur at any point in the machine learning life cycle. It can occur in your data generation phase due to accurate representation of the world naturally by itself has some bias. And if we are going to take the same, we might have bias systems as well. So we have to be mindful of what the data that we are using and over and under representation of the population, right? Like if you're in your data set, if you have data points from people belong to a certain group more than the other, that's a natural tendency of bias. It's going to learn the same way. Your system is going to learn the same way. So there's an over and under representation of the population and errors in feature label collection and selection. So that's for the data generation phase. And in the model building and implementation phase, if you're familiar with the data science concept, I think it's much easy to understand the point that I'm going to talk right now. But nevertheless, there is always an opportunity to go back and learn. So, model building and implementation phase, it can occur when you choose one objective function for performance evaluation over the other and using one model for all the underlying groups that need different treatment, misrepresentation of data and mismatch in the model use, and we have some evaluation and deployment errors as well. So to put it in a nutshell, it is critical that business owners look at the model in the context of overall ecosystem of where the data is generated and where the data is being used. So this is an important process in overall bias detection process. Having all this in mind, let's understand the toolkit that can help in bias detection and mitigation. So these are popular open source toolkits for fairness. Uh, Let me just go through, quickly read through it. A Fairness 360 Toolkit, FairLearn, What If Tool, Aquitas, Scikit Fairness, and LinkedIn Fairness Toolkit. So these are popular open source toolkits that are available for fairness, and each toolkit has its own set of features. Some has, you have metrics to detect bias, and some will help you visualize what is actually happening in your model and data, and whether there is any sort of bias towards a particular group of people. And we have this, psychic fairness, and we have, if you're building your, if you have big data and you want to deal with, big data, then there's a certain group of toolkit that you can use. So each toolkit has its own, pros and cons, and has its own set of features that will, and if you just club together, it's going to give you an effective, overall toolkit for your pipeline. So what we're going to focus today is on AI Finance 360 Toolkit. So, AFNS 360 Toolkit is an extensible open source toolkit for detecting, mitigating, and as well as explaining AI bias. So, it combines top bias metric, bias mitigation algorithm, and metric explainers from the fairness researchers across industry and academia. And the toolkit is available in both Python and R. If you want to get into the technical aspect, if you want to know the language that the toolkit is written and used, it's available in both Python and R. For me to get, into the toolkit a little more, I would like to introduce you all to certain terminologies. This field by itself is is has a lot of new terminologies that you might come across. I know we have this short session right now, but I want to make sure I provide you like at least 3 to 4 terminologies that will be useful for you to understand the rest of the session. First is favorable label. If you're again in the field of data science and if you're a data science practitioner, the moment you see the word label, you all know it's the outcome, right? So the label value here corresponds to the outcome that provides an advantage to the recipient, right? Let's say you are creating a loan application, so your system is going to tell whether you are going to receive a loan or not. So the advantage label, the positive outcome here is getting a loan, right? So the positive outcome, or the outcome that is advantageous to the recipient, is called the favorable label. And two other important terms that I would really like you all to take from the session is the protected attribute. Attribute is a feature. Let's say in your data set you have 100 features. So this particular feature is going to take your data set, is going to take your population and split into different group, right? For example, if your data set has race, sex, caste, and religion, if you take race, the particular race is going to split your entire data into multiple group, right? Race 1, race 2, race 3. And privileged value, for example, if you have three classification of race 1, race 2, race 3, and race 1, people who belong to the group race 1 always get positive outcome. So in that case, we call it as privileged value because they always get positive outcomes, so we tend to look them as a privileged group, right? An unwanted bias, of course, when we place a privileged group at a systematic advantage and unprivileged group a systematic disadvantage. That's when you get into the space of unwanted bias. So yeah, to put it in a nutshell, we saw four terminologies, new terminologies today. If you're not familiar with this space, favorable label indicates a positive outcome, protected attribute, the feature that's going to split your data set into group, privileged value, and unwanted bias. So this is a credit card, credit risk prediction application. It's going to say whether your application is a credit risk or not. Let's say people belong to sex male, usually get no credit risk, right? Usually get positive outcome. In this case, it's no credit risk. Then if you match this scenario with the terminology, our favorable label is the no credit risk. Our unfavorable label, like the negative outcome, right, is having a credit risk. And protected attribute here is sex, and privileged protected attribute here is male. That being said, let's get back to what is there in the toolkit, right? So this particular toolkit can be used throughout the AI application lifecycle. By this I mean you can use to detect bias in training data and trained model, and mitigate detected bias in the data used for training the model, in the model being built, and on the built model. First, let's see the pre-processing phase. I'm highlighting it here. Here we get the data, we clean, we process, then we use this toolkit to see if the dataset has any bias. If there is any bias, then we use the pre-processing algorithm to mitigate the bias. From here, we use the transformed dataset to build our model, and we go for the evaluation and so on. So we detect, we mitigate before building the model. Everything is happening in the dataset. And the next is the in processing. Here we again get the dataset, clean and process. Then we use the toolkit to detect if there is any bias in the dataset. If there is any observed bias, then we use in processing algorithm to build a fair classifier model. And the point to note here is we are not transforming the dataset. We are directly, you know, we are not transforming the dataset, but we are mitigating bias when building the model. And then last is the post processing phase. Again, we get the raw data, we clean and process the data and build the model. And then we use the toolkit to see, if there is any bias in the validation result. And if there is any bias in the prediction that we are, getting from the toolkit, we can use the post processing algorithm to mitigate the bias in the built model. And the point to note here is we are not transforming the dataset, we are not touching the model building phase, but we are directly, working with the model prediction, the built model. So this is where you can use this particular toolkit. And getting one step deeper into the toolkit has over 70 metrics and algorithm, and I have the next two slides to specifically educate you all on high level classification of fairness metrics. First is the group fairness. So I want to make sure I make it visual. I don't want just to deliver the concept. So I try to draw uh, the concept. It's my handwritten diagram that you're seeing on the screen here. So yeah, what is the group fairness? Here we again take a protected attribute, and then we partition your group or the population into group. Then we try to see some statistical measure across the group. For example, if you can see on the visualization, we have this entire population on the top, like entire your data set, and all your members are in the orange and white color, and the protected attribute here is 6. So I'm taking this protected attribute and I'm splitting them into two groups, the orange group and the white group. And I'm trying to see, as some statistical measure across the group. So that's group fairness, as the name says, group fairness. And next is individual fairness. As the name says, we seek similar individual to be treated in a similar way. So your protected attribute or the feature should not be a discrimination factor. All individual with the same feature should receive same predicted outcome, and individual with similar feature should receive similar predicted labels. And that's called individual fairness. And the other section of the toolkit is the algorithm part. The last two slides are about the bias detection part, and the next two slides are going to be about bias mitigation part. So, bias mitigation algorithm attempt to improve the fairness metric by modifying the training data, learning algorithm, or the prediction. They are categorized again into pre-processing, in-processing, and post-processing algorithm. We have about 10 algorithms in total in this toolkit. So, in the pre-processing phase, we deal with the data. On high level, the mitigation is done by augmenting the data set with additional data points, applying instance weight to the data points, and altering the labels. And in processing phase, again, if you're familiar with the data science concept, uh, it will be easy to grasp it quickly. So we deal with the model in processing phase, right? So we try to reduce the impact of the protected attribute in prediction. We add regularization term which is aware of the discrimination in the data set. We try to optimize the model for fairness metric, and you know in this in processing phase we don't want your deployment, the test data, to have the protected attribute. That's the advantage of this. And in post processing we deal with the prediction label. When you need post processing is, for example, if you are directly purchasing your model from the vendor to include in your pipeline and you don't have access with your data, your model building phase, and so on, that's when we enter into the post processing algorithm for the mitigation purpose. It tries to update the label and make it fair. So, together, the choice of algorithm depends on where we can actually interfere in the pipeline. If we have access to data, if we can modify the data, that's awesome. We can use the pre-processing technique. If allowed to change the model, we can use the in-processing technique. If the user can only treat the learned model as a black box without any ability to modify training data or learned algorithm, then in-processing can be used. And we earliest, early intervention is the best, and if possible, algorithms from all permissible categories should be tested. End of the day, there is no one algorithm that is independent of data set. It depends on the choice, depends on the data set, the business objective, the is not the all the ethics, design workshop decision, and so on. So you can find more in-depth guidance in the website here. So this is the AFS360 website. I will send you, the resources after the call. So if you go to the demo part, you will see some demo that will help you understand how the toolkit works. And you have the resources link here. If you want to know guidance on how to choose a metric, how to choose algorithm, then we can use the guidance. And this is the glossary term in general. If you want to understand, the fairness glossary term, there's a list of resources that's available, and I feel it will be useful. So we are done with the fairness part. Let me quickly recap you all whatever we have seen for the last 10 to 15 minutes. So we understood the concept of fairness, what it is, what are the types of bias, and bias can occur throughout the machine learning life cycle. So it's important for us to keep this in our mind when we are interacting with the data and model throughout the life cycle. And we saw the list of open source toolkits that can help for fairness detection and mitigation. And then we went in depth into a Fairness 360 toolkit. We saw high level classification of the fairness metric, group fairness, individual fairness, and what are the algorithm, and what are the the in processing, pre processing, and post processing techniques, and list of 10 algorithms that can help you mitigate the detected bias, and then some tips at the end to make sure we make good selection of the metrics and algorithm. To remind you all, there is no one algorithm that is independent of the dataset, and this requires detailed conversation with your stakeholders. a rigorous and completely involved design thinking exercise to understand how or what are the unintended consequences of the application. So once we have clarity on those, the unintended consequence of the application, what our stakeholders are want, what is the business outcome we are looking for, what are the ethical concern or the potential ethical concern that the application can have. After going through all this exercise, clubbing this with the toolkit and having a detailed conversation will be helpful. Again, this is a starting point. This toolkit is a starting point. It's not like you can take this toolkit and completely deduct and mitigate bias. It's a starting point, and a detailed conversation with the stakeholders is necessary. And the next pillar is the explainability. I'm not getting too technical. So if you're thinking, oh my God, why it is getting too technical? Sorry about that. I want to make sure, we all understand the concept better, the toolkit better. So that's the motive. So next is explainability. Let's, let's take a quick deep breath because it's not going to be super technical. I'm going to make it a little more interactive with a demo. So black box problem, this is something we all deal with when we are working with the AI system. When we don't know what is happening inside, we are giving some input, we get some output. It's awesome to see, but what is happening inside? Let's say you have deployed a credit card application and it's giving you a negative outcome that your application is rejected, right? Now, how will you know why the application is rejected? Like why your system is predicting or why your system is giving a negative outcome, right? So most of the time it's hard to reason it, and that's the problem. That's what we call as black box problem. And some of the question we might have is, why does the model decide to do that? How sure, the model is about the decision? How can I be sure that there is no bias? How can I be sure that the result is without any error? How can I trust basically the model outcome, right? As a user, as a consumer, we all have this question. I have this question as well. And if you are a stakeholder, right, each stakeholder will have their own set of questions. For example, if you're a data scientist who is involved in building the model, you really want to understand what is happening, you want to improve the performance, you want to know what is happening inside so that you can debug. If you're a business owner, you want to understand the model purpose, right, and evaluate. Only if you understand the model purpose on a high level, you'll be able to evaluate and make a decision about adding the model to your application. And if you're a model risk evaluator, then you got to challenge the model, ensure that it is robust, it doesn't get affected by any of the attacks. And if you're in a regulator role, then you want to check its impact on consumers and verify its reliability. And if you're a consumer, of course, and if you're impacted, that's even more hard. You want to know, what is the impact on me? Like, what actions can I take? What can I do with this, right? So each of us involved in the process will have our own questions, and that I had similar questions as well, and I came across this toolkit which helped me answer some of my questions, and I hope this will help you answer some of your questions in the process as well. So this is AI Explainability 360 open source toolkit, library to explain AI model and their prediction and the data set. So it basically gives you a local explanation about, local in the sense, explanation about each data point in your data set, and a global explanation, like uh, explanation about your model on a high level, right? So that's the AI Explainability Toolkit. And I'm going to quickly take you to the website here. This is AI Explainability Toolkit website. And this is a demo which it is lightweight, and I always feel it's easy to understand. This is an FICO explainable machine learning challenge, and the goal of this model is to predict whether the customer will make timely payments over 2-year period or not, whether the customer on high level will make payment or not, right? So that's the goal of this AI system. And let's see something. Okay, imagine you are a bank customer and you want to understand your application result, right? So as a bank customer, you really want to know why you received certain outcome. Let's choose Julia. So what this toolkit basically will help you is, it's going to tell, okay, these are the factors contributing to your denial. So your current value of consolidated risk markers is 77 and it needs to be around 82 for the application to get approved. And the number of satisfactory account is 10, it needs to be 13. And other delinquency score is 6 and it needs to be around 7. And here are the feature that actually led to the denial application denial outcome. So this toolkit on high level, it's going to explain you the reason. It's going to you know make you see the black box and understand what is actually happening inside. You must be having a lot of question about this toolkit, especially right now. And I want to be mindful of the time, but if you go to the resources, I know you really want to see the code if you're a programmer, and you must be having 1,000 different questions like I had when I encountered this toolkit. If you go to the code, you have a bunch of examples here that's going to tell you what is actually happening, right? If you want to know about the algorithm behind, if you want to know about the process, the parameters behind, you can take a look at this example code, that can help you understand what is happening. I want to quickly show you the idea. I want you all to get an idea of what this toolkit is about, so that's why I used the demo. But there's a good set of documentation that's available for you to understand what is the metrics, like what is the algorithm, what it does, and what is the math behind the algorithm, right? So I hope I gave you some points for the explainability part. And now is the transparency part. Transparency reinforces trust, and the best way to promote transparency is through disclosure. So these are the open source tools that are available for transparency: a Factsheet 360 Toolkit and Google Model Cards. So the what is Factsheet? Like what it does for you, right? The goal of Factsheet is to foster trust in AI by increasing transparency, which is like an increased understanding of how AI was created and deployed. And it enables governance, right? The ability to control how AI is created and deployed. So it's a combination of both transparency and governance. That's fact sheets for you. And this allows the consumer of the model to determine if it's appropriate to use in their application. And AI governance enable an enterprise to specify or reinforce policies describing how the model or service should be used and deployed. And what it will help you is to prevent undesirable situations such as model having bias, model having unexpected performance variation, and so on. We are transparent at the beginning. We tell you what the model is all about and what it is not, so we make informed decision about the model usage. This is not a new concept. Transparency fact sheet, again, it's not a new concept. Transparent report mechanism has been there for a long time. It's not new to us. Best example is you can relate this tool, the fact sheet tool that I'm going to talk about, with the nutrition label that you come across every single day in your food products and other nutrition products, right? And it provides information about the ingredients of the food product and the percentage of the value. So you can relate this transparency, the fact sheet concept, with the nutrition label. So in 2018, IBM Research proposed the concept of a fact sheet. So a fact sheet is a collection of relevant information or the facts about how the model is created and deployed, how the AI model or service is created and deployed. And the facts could range from information about what is the purpose and criticality of the model, what are the characteristics of the data set, where it is coming from, what domain it is, what it has, what are the data points it has, information about the model, service, and what are the actions taken during the creation and deployment process of the model. Right? Such models are created, AI models are not created just by one team or one person. It's created by various role, in machine learning life cycle. For example, it first it starts with the business owner, then a data scientist will come into picture. He's the one, the data scientist, the one who collects and transform the data set, machine learning algorithm, to construct a machine learning model. And we have this model validator is a person who tests and validates, or validates the AI model developed by a data scientist. And then we have this model operator, who is a person who deploys and monitors an AI model. So, it can be used by others. So, as you can see, it's going through, a lot of roles, and there are a lot of people involved in the process. And how can we get the facts right? How can we make sure we know what's the decision taken throughout the process, right? So that's where the fact sheet is going to help you. Each of the many role in the life cycle contribute facts about the facts about how the model was created and deployed. So in 2019, there was another paper released which describes the experience in completing a fact sheet. And the key takeaway is there is no one set of question for the fact sheet. It's going to change by project, by person to person, role to role, and regulations and industry requirement, and so on. As I mentioned earlier, to recap, this AI Fact Sheet 360 tool, it combines your transparency and governance into one toolkit. So I keep telling about the fact sheet, right? What it has, like what they really have. So we have a template here, we have set of question, and we have set of known facts. We are going to put this question and the known facts together to create this fact sheet. And the fact sheet comes in various format. You can create a fact sheet in a Jupyter notebook, a web tool, a PDF. It can even come in JSON file or a presentation or a short and long format. Okay? So this is the fact sheet. Let me quickly take you to this website and show you how the fact sheet will look like, so that you can understand what I'm talking about. So this is an example of the fact sheet. This is an object detector model. So these are some of the sections that we have. Right? Overview: what is the purpose of the model? What is the intended domain, like where the model can be used? Information about the training data. What are the objects? This is an object detector model, right? So in your data set, what are the objects you have and how many data points you have under each object? And model information, architecture of your model, input and output, performance metrics. If there is any bias deduction that that the model went through, then information about bias, robustness, and test data. Optimal and poor condition. We are being transparent here. We outrightly tell you when the model will work and when the model will not work, right? So these are some of uh, sections that can be included in a fact sheet. And as you can see, it increases the transparency overall. Right now, clearly when the model will work, when the model will not work, what is the data set being used, what are the decisions that were taken throughout the process, right? So this is an example of fact sheet layout. So quick recap: we saw fairness, we saw expandability 360, and then we saw about a fact sheet 360. for transparency. So, getting back to our trustworthy AI pillar, we saw about fairness, A Fairness 360 Toolkit, A Expandability 360. For transparency, it fact sheets. For robustness, I didn't go through the robustness toolkit. It's adversarial robustness toolbox if you want to learn more about it. And we have the privacy, and I have link in the resources that I can share after the call. So I hope this session actually helped you to understand the open source toolkits that are available for building the trustworthy AI system. I want to conclude with this note from my end, which I think is really important. Building trustworthy AI system is not possible just with tools. For example, you can ask me, I have this tool. Can I go detect, mitigate bias, increase transparency, and so on? Is it 100% possible? If you're asking me, no. Tools cannot 100% solve the problem, right? It's going to help you solve the problem, but it's not the solution to solve the problem. What it takes is the complete culture change of the organization and having a strict governance around the process so that we can use the combination of tools, culture change, governance to move towards building trustworthy AI system. We need to consciously come together to build better system and future. So the tools are the tools, right? They are going to help you, but we have to consciously make decision, do proper design exercise, understand the unintended consequence of your application, and have a good culture change in your organization that will effectively take you towards this path of building trustworthy system, and then have a good governance around, right? Hope I empowered you all with tools that you can use in your journey of building trustworthy AI system. And I'm available on LinkedIn if you want to really chat about it. And I can send you resources offline as well so that you can connect to us on Slack. And happy to discuss more about uh, the process, the tools and concepts if you are interested. Again, thank you so much for joining me today, and again, gratitude for all your time and efforts. Thank you.
Thank you. Thank you so much, Saishruthi. And it was immense and hugely helpful,
Thank
your session. And, I was just going to tell people to connect with you on LinkedIn to take the learnings forward. I know you didn't have the time to talk through every one of those five sections this time, but those of you interested, and we are certainly interested, please connect with Sai Shruti on LinkedIn. You'll find her. I found her profile as well. And on that note, thank you so much, Sai Shruti.
Thank you so much. I hope it's useful and helpful and it has empowered you all in a certain way.